Hello and welcome back to Reigate College Maths post-Easter work. This is week 2. We are looking at sequences and series, and this week we are focusing on a little bit more general sequences and series work, starting with sigma notation. So some of you may well have seen this before. We are going to be using this, which is the Greek capital letter sigma. Which, again, some of you may already know, generally means sum or add things together. Now, what we're going to do with this is we're going to say something like sigma of r from r is 1 to 4, for instance. So this is the lower limit, and this is the upper limit. So what this tells us is we're going to add together this formula when r is 1, when r is 2, when r is 3, and when r is 4. So this is your starting r value, and this is your final r value. So what we're going to do is we're going to put increasingly larger integers into this formula here, which in this case is just r, up until we get to this number. So this is going to be 1 plus 2 plus 3 plus 4, which is 10. Okay, now if we have a slightly more uncomfortable nth term formula, like this, for instance, what we're going to do is we're going to put 1 into this formula, then put 2 into the formula, put 3 into the formula, and put 4 into the formula, and then add all the numbers together. Okay, so this is 2 plus 5 plus 8 plus 11, which is 7, 15, 26. Okay, so if you notice, this is also, this example here is an arithmetic series. 2, 5, 8, 11. It's an arithmetic series with 4 terms. So this is this here is an arithmetic series with n equals 4. Your first term is 2, and the common difference is 3. So we can also think about these in terms of the nth term formulae that we looked at last week. So you can see, therefore, is going to be same as the sum of the first 4 terms of this series. So it's n over 2, 2a plus n minus 1 times d, 2 times 4 plus 9. This is 13, which gives you 26. This is really useful if you have a really long series. Okay, this was very short, so we can just do 2 plus 5 plus 8 plus 11 and get 26 quite easily. But here, this is a much
quicker method if you have a very long series. So let's do another example with that kind of thing. So let's look at the question 1 from page 7 of the workbook. Okay, so we've got evaluate, so work out the sum from r equals 2 to 7 of 2r plus 1. Okay, so what we can do, and what I would always advise doing, notice how this doesn't start with a 1. It doesn't have to, but if it starts with a 1, then you can use the summation formulae straight away. If it doesn't start with a 1, then you've got to be a little bit more careful. And what I would always do with this type of question is write out the first term. So the first term is 2 times 2 plus 1, so 5. The second term is going to be 2 times 3 plus 1, so 7. And the last term is going to be 2 times 7 plus 1, so 15. Now again, we don't want to write all of the terms out. With this, again, it wouldn't be too bad because there aren't many terms, but if we have many, many more, it's going to be more difficult. Okay, but let's think about how many terms we've got. So this is when r is 2. Next one when r is 3, when r is 4, 5, 6, 7. So we've got 6 terms. So this again is arithmetic. We've realised we've got 6 terms. Our first term we know is 5, and our common difference we can see is 2. So therefore, the sum from 2 to 7 of 2r plus 1 is going to be n over 2 2a plus n minus 1 d. Equals 60. There are other ways to do this question in terms of looking at, well, what happens if this is 1 and things like that. The thing where that idea becomes really useful is what happens in cases like this. So this is not an example from the workbook. Let's say that. Okay, the sum from r is 20 to 30. 20 to 40 of 3r minus 1. So we could do like we did here, work out the first term, work out the last term, work out how many terms we've got. Or another way is we can say, okay, this is going to be when r is 20 plus when r is 21, 22, all the way up to r is 40. Well, we can work out this by using our summations and our formulae from last week. Okay, because this looks like an arithmetic formula. Notice we don't have 3 to the power of r, we've got 3 times r. That means this is arithmetic. So we can work out how many terms we've got. So we've got 40 terms. We can work out the common difference, which is 3. And we can work out the first term. if we subtract from this, so remember this is from 1 to 40, if we subtract 1 to 19, that gives us the 20th term. So this is 1 plus the first plus second plus third, all the way up to plus the 19th plus the 20th plus 21, all the way up to plus 40. This is 1 plus 2 plus 3, all the way up to plus the 19th term. If we take this off, then that gets just this. I'll show you what I mean. So this here is that. Okay. This bit, the thing that we want here, is just this section. So if we subtract this bit, which is that lot of stuff, from the whole thing, we get what I've bracketed in pink. So we can see these are two arithmetic series. This one has 40 terms, this one has 19 terms. So, colour pen. We know that this is therefore equal to 40 over, so n over 2, 2a, which is going to be 5, so 3 times 1 minus 1, plus n minus 1 times d. You can see the common ratio is 3. If you can't spot that immediately, then again, put some numbers in. This is going to be 5 plus 3 times, no, first term's not 5, first term is 2. But we can see then the second term is 5. So second term is 5, yeah. 3 times 2 minus 1 is 5. Then 3 times 3 minus 1 is 8. So we can see the common ratio is 3. And it's this number here. So this is this first bit. And we want to minus the same formula, but with n is 19 instead of 40. Okay, so once you're there, what I would do is put each of these bits separately in your calculator so you can show appropriate working. Okay, so we've got 20 times 4 plus 39 times 3, which gives us 2,420 minus 19 over 2 times 4 plus 18 times 3, which gives us 551. 2420 minus 551 is 1869. Now, the good thing about these calculators is we can actually check that using the functions. So if you notice here, we can see you've got this sigma, so shift and then X button here, you can see we've got sigma. Now the calculator uses X instead of R, but that's okay. So here we need to type in our X term formula, so 3x minus 1. Here we've got 20, here we've got 40, and you can see that's the 1869 we got. As I said, you could do it in this way as well. That would work fine, but this way works as well. It just depends on the wording of the question and what you need to do. So this is what happens if the sequence is arithmetic. We can also do the same thing if the sequence is geometric. So if we now look at question 2b on page 7 of the workbook. So 2a, do have a go on your own. It's like we've just done. The final answer is 40. Okay, so part B, we've got the sum from n equals 3 to 8 of 2 times 3 to the n. Okay, so because this has got a power here and we're not adding anything, this is a geometric series. So we know we need a first term, a common ratio, and a number of terms. Okay, so let's think about this. The first term is going to be 2 times 3 cubed. Which is 54. Plus 2 times 3 to the 4. Which is 162. All the way up to 2 times 3 to the 8, which is big. So hopefully you can see the first term here is 54. The number of terms we've got when n is 3, 4, 5, 6, 7, 8, you have 6 terms. Now the common ratio, hopefully you can all notice that it's 3. But if you can't, let's double check. Remember, the common ratio is the second term, 162, divided by the first term, 54. And we get 3. So we know the sum from n is 3 to 8 of 2 times 3 to the n. We use the summation formula. So a times 1 minus r to the n over 1 minus r. (54) 1 minus 3 to the power of 6 over 1 minus 3 gives us 19,656. And we can see there, again, this is one way to do it. You could do the alternate method of doing the sum from 1 to 8 minus the sum from 1 to 2, if you wanted to, like we did before. And you would end up with the same answer. Okay. This also you wouldn't have to use the formula for, because you can just go, okay, well this is the sum from n is 1 to 8 minus, we know the first 2 terms because we worked them out. Again, another way to do the question. Right, so to practice that, what I would like you to do is exercise 3F, which is on page 77 to 78 of the workbook. Remember, you can get that on Active Learn. What I would like you to do, please, is question 1. Question 3. Question 4. And question 8 and 9. Then the challenge. So the stretch and challenge questions, what I'd like you to do is questions 11 and 12. Something important for question 6, if you fancy having a go at that one, question 6 and 7, are some formulae for general summations. So, if we add all these numbers together, we've seen this sort of result already. This is the sum from r equals 1 to n of r. And that is the general formula for this summation. If we add a number together, n times, that's that, and it's just n. If you multiply these by any number, so let's say we had 2 plus 4 plus 6 all the way up to plus 2n, that's the same as this with 2r, you can just times this formula by 2. Okay, so going back to the questions. Exercise 3F, page 77 to 78, those questions there. Once you're done with that, what we will do is you can come back to the next video and we will have a look at another way of describing sequences and series that maybe cannot be categorized as arithmetic or geometric.